Hey guys, what's up? Eddie Alho here with KissAnalog.com. Hey, St. Patty's Day. Happy St. Patty's Day. Hope I'm not overdressed for this, but you know, hey, so by the way, I'm sneaking out to go skiing. We have family from New York in, so I've got to make this quick, okay? Hey, Abusive Ben, I know you're chuckling right now, but I'm going to make this quick, honest. Superlicious dude asked about active loads, so I'm going to use this Kunkin. I also have this guy back here, KP184. We're going to use that guy in other videos, and we'll do more videos of this if you guys like this. I don't have time to go through all the modes of operation, so constant current load on this active load, we're going to show what that is, okay? And hold on a sec. So this, okay, you can get this on Amazon, by the way. This is a nice little load. I got this because I didn't want to spend a lot of money, and these are kind of like picking out power supply, kind of similar price range and so on. I think this is a little over 200 bucks. It's got a nice little rubber feet, some vents on the bottom, vents on the side here. You can see that, vents on this side. Eee. Let me pull these out so I don't tear apart my test setup. And it has a fan back here, if you can see that. And it pulls air through these vents and through the bottom and out the back. And it's very quiet. You don't hear much. Very quiet fan. Has an RS-232 port. Comes with the RS-232 cable. And it has this other 485 port. Comes with the connector here. You can hook up little screw terminals there. And if you want to use 485, so there's some software. I've seen in the manual. Haven't tried that. This thing is very intuitive, so I just you know, once you see what I do today, you'll kind of know how to get your way around one of these things. But we're gonna do some other videos on some of the other modes. There's a thing here, selector for 110, 220 for US voltage, because it comes with the US thing. Fuse here behind this little panel, power switch, and that's pretty much what there is. There's this port here you can use, a BNC connector. You can use that for remote monitoring. So you can use something like this, a BNC with connectors here on the end to monitor the voltage over at your load. So it takes kind of nullifies the voltage drop that you get across your cables that you've wired to this for constant. Anyway, so yeah, you can use remote monitor. It comes with connectors there. Hold on a sec. All right, I'll just show you real quick what this thing came with. Came with the calibration card and comes with a small manual. It's written well enough, I think, to help you get around this, especially after you're watching these videos. I think you can help show some software, a GUI here that looks kind of interesting. Here's a little sticker that has different things on the modes of operation, and I think you can stick that on the side. Maybe I'll do that, so once I learn what all these different things are, I can quickly look at the, you know, use that as reference. Here's that 9-pin RS-232 cable, and it came with some black and red cables that were probably a meter long, 3 or 4 feet long. No connectors on it, but it's meant to use for hooking up loads. I used it for building a power cable on the Power Supply Design Series, if you've seen that. I think that's where I used that. So I use these guys with the banana jacks. I get these from Amazon too. You know, I'll try to put links for these things. It also comes with this BNC. It has a nice little spring. Just here, I'll show a close-up of this. So this, you can hook up a cable into this and do remote monitoring if you like. So maybe you can see that. Comes with, it looks like it's gold. I don't know if that's gold or not, but anyway, it looks nice. It has a, you know, this little spring thing here for tension relief, and these little red and black spade connectors to build a cable. But you can also buy one of these on Amazon really inexpensively. And you know what, honestly, this one here is new. It might have came with this one. I'm not sure if it did or not, because I bought a bunch of stuff from Amazon, so not sure if it did or not. Alright guys, let's jump in this video and get done with so I can do some skiing. And I got a little thing I have to go, you know, celebration, so I'll put this thing back on and do that tonight. So hey, thanks for watching, and let me know what you think of this. Hey, by the way, I'm curious how the rest of the world celebrates, or if they do celebrate St. Paddy's Day. I know we have people from, gosh, all over the place: Netherlands, England, Germany, I think Denmark, and gosh, I'm sure I'm forgetting other countries, but you know, I'm just curious where and if you guys celebrate St. Paddy's Day. So, alright, hey, thanks guys for watching. Okay guys, so this will be the setup, the Tektronix power supply, the PS2521G programmable. We're going to have it in parallel mode, so it says parallel here. That way we can get the maximum current if we want, 5 amps, that's where I've got it set, and 10 volts. And we're going to show that as we increase voltage up and down, we're going to draw whatever current we set here for constant current. Okay, CC is constant current, and down here this is constant voltage. The power supply is going to try to put out that voltage. It doesn't care what current as long as it's not over 5 amps. 5 amps is the max. And channel 2 is this output 2 here. So in parallel mode, output 1 and 2 are both putting their max current. Each one has 2.5 amps, so in parallel they can put 5 amps out. Okay, and we're going to use the GW Instack MDO2204EG oscilloscope, the new scope I have on the bench here, and we'll be just looking at current. And I've got it down here, you see the marker 2, and right now it's set at 1 amp per division. So I've got this guy set at 4.8 amps. So I just set this with this dial. So I'm going to say 4.8. I can use these arrows to set 8, like that. Or I can come all the way over here and set this guy. So I can use this arrow like that to move what digit I want to move. And if I go like that, I can go 5.3, 4, you know, so I can go, I'm going to go 4.8, so I'm just below the maximum here, okay? Now this guy's capable of 40 amps, so we're just barely exercising this guy. So here we go, and this guy is set at 20 milliseconds per division. So that's how we got it set up. Now let me show you how the wiring is set up down here. Okay, so let me show you the wiring down here. We're going to come from the power supply, come through the Handtech. We're going to go through the Astro just to compare the readings from the Astro to the scope readings, and then we're going to come up here to the active load and back to the power supply. That's the current loop. So see, red comes down, goes through the Handtech, goes into the face of the Handtech, out the back, and then into the 10 amp setting of the Astro, and then out of the common up here to the load, out of the load back to the power supply. So that's our current loop. So that way we can measure, the Handtech can measure it. I'm going to hit this degauss button sometimes. You won't be able to see the Handtech. I'm going to get the screen so it's zoomed in so you can see this and this and this and this, but I don't want it to be zoomed out too far you can't see things very well. So now let me just go over the scope setting. Okay, we're not going to use the voltage setting. We're only going to use this current probe. I guess I could just disconnect that. So we're just going to use the current. We're going to channel 2, and we have it set, you know, for 1 amp per division and 20 milliseconds per division. And right now it's triggering on the down slope. Let's change that. I'm going to go on up and down so I can capture rising edges or falling edges. Okay. Now for this guy, it's going to be invert is off, impedance is 1 meg, coupling's DC, and current probe. It says current probe. It's when I push this, I can say voltage probe or current, and it's on 10x setting. I can set it variable, but I'm going to go 10x because that's where the probe is set. So now it says current probe 10x. That's what I want. Turn off the menus. I love how the menus disappear on this scope. That's great. Gives me all the screen back. Okay, we're also going to hit this single trigger button to capture the rising and falling edge. That would be this button. And we're going to start off with run stop, so it's just continuously capturing or triggering. But then we'll go to single mode where it'll wait. See, it shows trigger question mark. It's like, hey, where is it? So as soon as it sees a rising or falling edge, then it'll trigger. And I've got RMS measurements down here, and right now it's says 41 milliamps, 160 milliamps peak to peak. So let's go back to this. Whoops. And it's, yeah, so it's just capturing some noise down here. It's 1 amp per division. Now I'm going to hit the degauss. Okay, hit it a few times, make sure it's degaussed. So it's dropping down to 19 milliamps, 120 milliamps peak to peak. So that's just kind of the noise level on the current probe, but looks pretty good, I think. And by the way, I do have this on bandwidth limit 20 meg. I could go to full bandwidth or 100. I could go to full. It just shows a little bit more noise that way, but I'll leave it there for now, just to show we're not missing anything. Okay? Alright, so I'm going to zoom in here just for a moment so you can see the left right arrow button, the up, down. It says clear underneath this one, so you can hit the shift key to get clear or save, recall, battery, or menu. So you can make this thing act like a battery, and you can drain. You can put this as a load to a battery and it'll do amp hours. So we're going to show that in another video. But here's the menu button, recall. Now let me just show you the menu button quickly. If I go, well, here, let me show you the mode. Okay, so once I've hit shift menu, it has this async menu, and then it has B configuration, sense, local. So you go sense or local. Right now it's local, or I can go remote. And here's the battery enable. Right now it's off. And this Copay, I'm not sure what these things are. We're going to learn about this. Here's Dyna, so if I want to toggle on and off between loads. And here's another mode, I don't know what it is yet. So those are the different modes, okay? Okay, so I just turn off the shift. See, I'm kind of intuitively learning this right now. Now, if I go to mode, I can go to CV, constant voltage, constant wattage, constant resistance, constant current. And then here's the battery mode over here if I hit shift battery. Okay, so we're not going to do that. We're going to stay in constant current. And over here you can see the CV, constant voltage, the parallel mode, and channel 2. Okay, 5 amps maximum current. It'll only put out 5 amps before it goes in current limit, and it'll try to put out 10 volts. Okay, so constant voltage is going to regulate voltage. Okay, so now let's zoom out and look at the scope, and we're going to play around with this guy. Okay, now what we're going to do with this is we're going to set it to 4.8 amps, and then I just say, once I have it set, like I do now, see how I set this, then I say set, and then now it's in monitor mode. It's waiting to see what's going to happen, and when I push this here, I'll just push it so you can see what happens here. Whoops, I got to turn on the power supply, right? Output on off, there's on. Now it's in monitor mode, so see it's monitoring 0 current, nothing's happening right now, and the output light is on. Okay, now I turn this on, see, it's drawn current. Now this guy's measuring 9.45 volts, so maybe there's a little bit of voltage drop. Okay, and 4.7, 4.8 amps, it's 4.797, 4.8, so it's trying to regulate it, and that's about 45.3 watts. Okay, so see how I can now when I move this, I have to go to set to move the current so I can drop it down. Now you notice when I do this, we're going to look at what it looks like on the scope, but let me just, while we're zoomed in here, let me just show you. If I drop this down to 0.8 amps, see 0.8, 10 volts. So it's just constant current. It draws whatever I tell it to. See that? and it's putting out 10 volts. It's just constant voltage. This putting out constant voltage. This guy would take whatever constant current I tilt it to. Now watch, if I go to 5.8 amps, it's going to make this guy go in current limit. 5.8 amps, this guy drops down to 0.7 volts, it's in current limit, 5 amps. It's trying to put out 5 amps. And oh, here, let me hit the set. So this would be a monitor mode. So it's drawing this much current. The voltage says it's 0. This guy says 0.7. This multimeter down here is that you can't see right now is probably dropping some of that voltage because it has a shunt resistor inside it monitoring current, right? So 0 watts because there's 0 volts. So now if I go back to set and drop that back down, the voltage pops back up to 10 volts and it's constant current. So that's what a constant that's what electronic load does in constant current mode. Okay, that's it. Now we're going to just pull out and look at the scope, and we can look at the multimeter too. Okay, now you can see the multimeter. It says 4.78 amps, pretty close to that, pretty close to this. Here, let me go into monitor mode, so I got to say set. Okay, so it's just monitoring, I guess. 45 watts, 9.4. Okay, so that's what it looks like over here on the scope. You can see the set point down here, the current's up here. Now you notice this wavy stuff. We're going to talk about this a little bit more as we go on. This is something I've just learned doing this video, is that there's 640 milliamps peak to peak ripple on this active load. I think it's because it's capable of 40 amps and we're only drawing about 10% of the load. The signal to noise ratio, because this is what I call noise, it should be a flat line. So the signal is about 4.8 amps and the noise is about 600 millivolts peak to peak is the way I look at that. So that's the signal to noise ratio. And now watch when I lower this current. Here, I'll go to set so I can lower this. 3.8 amps, 2.8 amps, 1.8. Now remember, it's 1 amp per division, so it's 2 amps, and we're at 1.8. This says 1.8, and down here we're at 1.8. So that's a constant current, okay? That's what I want to show you. The last thing I have left is I want to show you how we can do a load step when we just turn this guy on. Now this has the dynamic load setting where you change from 2 different current levels. I'm just curious what will happen if we just say on off. Sometimes things are designed to have a ramp, a current ramp. I want to see what this is. So let's do that. Let's bring it back up to its max. So we go to 4.8. I can go to 4.9 really before this guy current limits, right? But now if I go to 5, it's current limited, so I want to go back down to 4.9. I'm going to go to its max, okay? So now I'm going to say off. Now, so let's go into monitor mode, so I'm going to say set. So it's 0 current, 0 watts, 9.9. And over here we have 0 current, 10 volts, okay? When I do on, it's going to pop up, and we're going to draw that current. Okay, now let's just capture this. So we got to, okay, I'm going to hit the single, here, let me zoom out for just a moment. Okay, I'm going to hit the single capture over here on the scope. See over here, the right side scope, I'm going to hit this. Okay, now it's question marks on trigger. It's waiting for something to happen. Let's turn it on. Oh, it got the, I just turned it off. okay, fine. We got turn off mode. So now it's in the center screen. Here, let me zoom in on that. Okay, here's the waveform we just saw, and here's the zoomed in version. I've already kind of zoomed in on that. See, we stretched out. So we got about 2 divisions at 10 microseconds per division. Let's turn off this menu. There we go. 10 microseconds. So we got about 2, so it's about 20 microseconds for about 5 amps. So I'd say that's pretty darn fast. It drops 5 amps in 10 microseconds, almost 5 amps. Okay, let's turn it back on and capture that. So that's a pretty fast drop. So if you're looking at the voltage, if we were monitoring the voltage too, we could see if the voltage did a little jump or something. Okay, so I stuck the voltage probe on here real quick, okay? Got the voltage probe. I've got it set at 2 volts per division. I turned it on, and so 2 volts per division. Right now it's reading 9.92 volts, 9.99 here, 10 volts here, and 0 current, 0 current, 0 current. Okay, so now zero currents everywhere. I'm going to turn this on and see if we get any overshoot or undershoot on the voltage. Okay, so go to single mode, and I'm going to turn this guy on. Cool. Now one thing I wanted to see is how fast this guy, yeah, I want to see how fast this thing came up, but right now I can see that there's no overshoot here or undershoot here, so that's really nice that the power supply is regulating that way. Let's zoom in. We're capturing the waveform up here. Let me turn this menu off, capture this. So, okay, so let me zoom in a little bit more. Okay, I'll move this over a little bit. Alright, there we go. So it's come up to about max here. It's about 1, 2, 3, 4, 5, 6, 7, 8, about 8 divisions. And this is 1 millisecond. So it's about, just make sure. Yeah, it looks like that. Okay, so I just zoom back out, so it's 2 milliseconds right there. So it's 2, 4, 6, 8. Yeah, it looks about okay. If I I zoomed it out so that we can make sure that it's come all the way up. I move this right to the edge of the screen. Okay, so we got 1 millisecond per 1, 2, 3, 4, 5, 6, 7, 8 to 9 milliseconds. It's maxed out. So I'd say about 8 milliseconds, maybe 9 milliseconds that it's come up to max, and the voltage looks steady. So it wasn't fast enough to cause any disturbance in the voltage. Okay, now let's turn it off, see what that does. Now I've moved my trigger way over here, so I'm going to move this back in the center screen. I think I just push this button in. Let's see. Oh, position. Oh, good. So I just pushed the position button in, it dropped it right here in the center, but I pushed the trigger button first and centered that. I'm going to raise that up. Here it's telling me where I'm going to trigger. So I'm going to trigger it, say 1 amp. Okay. Now let's turn this off. Actually, I want to trigger it a little bit higher. Let's go where it first starts to drop. Say, we'll put this right in the middle. How about that? Let's go 2.5 amps. So I'm watching this, 2.5 amps roughly. Okay. Let's just turn this off and let this. I've got this in single capture. It says question mark, so it's ready. So let's turn this off. Cool. Now look at that. The voltage did actually have a little glitch right there when it turned off. It turned off really fast. Let's spread that out. See, here, I'll turn off the zoom for a minute. See, there's the screen, what we'd see. See that little glitch right there? With the deep memory that this scope has, I can zoom in, and it's captured all that stuff. So I can, here, let me zoom in a little bit closer. I can get really close, I think. Alright, so I've got it stretched out. This is 10 microseconds per division. It's roughly 2 divisions, 20 microseconds that it dropped. So it dropped really fast. And you can see how the voltage just kind of jumped up just a little bit. Here, let me turn off these menus. So the voltage says 640 millivolts peak to peak. So it jumped up almost half a volt. Here, let me zoom out a little bit and let's look at this voltage. But that was a fast turn off. That was pretty fast, 20 microseconds and 5 amps. Yeah, so you could see how this jumped up and came out. Now we could put this in AC mode, the voltage, so we're just looking at the thing here. Let's do that real quick. I'm going to go to AC voltage setting, channel voltage, go to AC coupling. Now we're going to move this position right in the center of the screen. Let's push the button in. Okay, moved it in center. Get rid of the menus. And then right now it's 2 amps per division. Let's go to, or 2 volts per division. Let's go to 1 volt per division. Okay, now we can zoom in on that, on the voltage, on the AC part of the voltage. So let's turn it on again. Capture that. Okay, it jumped up. I don't really see anything happening there. Here, I'll turn off the zoom. See it, you know, there's a little bit of noise here, but that's about it. Okay, with the zoom turned off, let's go back into single and turn it off now. And you can see that little glitch. Turn on the zoom, and you can see how it jumped up and came down like that. So I could even zoom in a little bit closer. Let's do that. See, it's kind of digitized there. Let's try that again. Now I'm capturing just a little slice of this. Let's see if the acquire's on 10 meg. That's maxed out for memory. So let's change. Let's go out of zoom, and instead of 20 milliseconds, let's go 10 or even 5 milliseconds. Okay. Now let's capture that again. Turn it on, and then single capture. Turn it off. Oh, look at that. Okay, so that's interesting. It looks like a higher glitch there. So let's make sure. See, this is where deep memory comes in. Let's zoom this in. See how that popped up? Now I've got this amplified now at, turn off these menus, at 200 millivolts per division. So it jumped up about 400 millivolts and it ramps down, but then it undershoots. Let's zoom out a little bit. See, then it undershoots just a little bit and it comes back up. So that's where that 512 millivolts came from. So with it zoomed in like that, that's how you can capture AC voltage mode. So, okay, so that's good. We got to see how to use a scope a little bit better, capture this kind of thing. And so that's how you can use an active load to exercise your power supply and test out a power supply. So, alright, hey, I hope you guys like that. Give me a thumbs up if you want to see more of how this thing works, okay? And hey, thanks Super Silicious Dude for asking for this. Thanks a lot, guys. Hey, go have a happy St. Patty's.